All right, today we are taking on variability. So chapter 1.7, measuring variability. So being able to describe the shape and center of a distribution is a great start. However, we have two distributions that can have the same shape and or center but look quite different. So case in point is this example right here. So we're looking at bowling scores. We're comparing Earl to Kelly. So when we describe their shapes, we would say, well, both of these distributions are unimodal. They're both roughly symmetric. And if I was to place the center for both of them, I would put it right about here at 150. So let me write that to the side. So both distributions are unimodal. And symmetric, right? Roughly symmetric. With the center approximately 150. Okay. But then when we're looking at their variability, when we're looking at their spread, we can see that Earl, his data is much more widespread compared to Kelly. Kelly's is concentrated more tightly around where that mean is. So if I'm comparing who's the more consistent of the bowlers, I would have to go with Kelly because her data has less variation, less spread to it compared to Earl. So let me add that little note too. So Kelly is the more consistent bowler compared to Earl. Okay, and that's really because her data has less variation. It's more concentrated around the mean. Earl's is more spread out in relation to the mean. Okay, so let me just say that one more time. So their shapes match, their centers match too, but we're saying that Kelly, she appears to me more consistent than Earl because her data is more tightly packed together in relation to the mean. Earl's is much more widespread. He has more variation compared to Kelly. Okay, there are several ways to measure the variability of a distribution. The three most common are the range, the interquartile range, we call that the Iqr, and standard deviation. So range is pretty basic, right? We're looking at the large value, the maximum value, minus the small value, that's our minimum value. So your range ends up being just a single number. So here is an example. So here we're looking at football data. So during the 2013 NFL regular season, the Denver Broncos had an offensive explosion, setting a new NFL record for total points in a single season up to that game. Over the course of 16 games, the Broncos scored 606 points. The number of points the Broncos scored each game is given below with a dot plot. Find the range of the distribution. So we're given the raw data right here, raw data, and then we're given a graphical display, so a dot plot. So we should be able to see that this is our low value, this is our minimum value of 20. I can always check it with my data up here. There's the 20. Okay, and then the largest value right here, the maximum value, is 52. And again, I can check to make sure that that's my largest value, and it's right there. There's my 52. So when I'm looking at my range, range is the max minus the min. So we're looking at what is 52, take away 20, and we get 32. So our range is 32, right? That's the distance the low to high are apart. Okay, but the range, often not super helpful because it's not a resistant measure of variability. it depends on only the max and min values, which may be outliers. So we know that outliers could have a big impact on the range. So let me say that back. If we have a distribution that has outliers, that would be the maximum and or the minimum values. So it might make it appear as though the data is more spread out than it actually is because of those outliers being present. All right, so here is another way to visualize why the range is not a perfect way of looking at variability. So here we have parallel dot plots that show the lengths in inches of a sample of 11 nails produced by each of 2 different machines. Both distributions are centered at 70, so it looks like my center right there is 70. They're symmetric, so that could be the mean or the median. Let's see, and then they both have a range of 4. So the range is the same as well. So where they're getting that range from, let me just point that out. The range is the same. So again, they're looking at max minus min. So range would be 72, take away 68, and that's why we're getting that figure of 4, right? They both have a high of 72 and a low of 68, so the range is 4 for both of them. But when we're comparing them, right, they have the same center, they have the same range. This one right here is unimodal. This one looks bimodal, right? They're both symmetric, but in a very different way. This one, the data is more tightly concentrated around where that center is. And here it's not. I see more data here and here on the bookends. So machine A technically has less variation because the data clusters more tightly around that mean or median value of the center at 70. Here in B, we see it's more spread out because I have more data over here clustering around the bookends. So let me write that. So here, machine A has less variation because the data is clustered more tightly around that center. And we're saying, well, that could be actually the mean or the median value of 70. All right, let me get to that second sheet next. All right, so the second sheet here, we're heading into the IQR, the interquartile range. So we can avoid the impact of extreme values, outliers, on our measure of variability by focusing on the middle of the distribution. So if we have our data organized from small to large, we can find our quartiles. So our quartiles divide the distribution into 4 groups of roughly equal size, right? It breaks it into quarters. So here we're looking at this distribution. We're looking at the amount collected each hour at a local charity. So we have right here is our first quartile. Let me draw in where it's saying that falls. So first quartile about right here. Third quartile, make sure we can see that right there. And then here is our median. That's our second quartile. So we often use Q1, Q2, and Q3 for those values. Let me put Q2 here so you can see it as the second quartile. So quartile is for quarters. So here I see the first quarter, the second quarter, the third quarter, and the fourth quarter of the data. We essentially have 4 groups of the same size. I have 3 pieces of data here, 3 here, 3 here, and 3 here. So 4 groups of 3 values. So then when we calculate the interquartile range, we're looking at the third quartile, so this measure right here, minus the first quartile, this measure right here. So it measures the variability or the spread in the middle half, the middle 50% of our distribution. So the middle 50%. So it gives us an indication of how spread out our distribution is from this span right here. So the middle 50% of data. All right, so let me walk you through an example. So here we have a set of data. We want to find the median, the lower quartile, the Q1, the upper quartile, the Q3, the range, and the IQR. So here we have 19 pieces of data. So let's start with that. So if I have 19 pieces of data and I want to get my median, to find the position, I do 19 plus 1 divided by 2. So 20 divided by 2 is 10. So I'm looking for what's in the 10th position. And I know it's going to be a standalone value because I had an odd amount of data. So what's in the 10th position? So I already have it sorted for you nicely. It's in ascending order, low to high. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So right here, right there is the median. It is also the second quartile, so I'll write Q2 next to it as well. So my median has a value of 6. So now I want the Q1. So when I want the Q1, what I do, since it's an odd amount of data, I block out the median and everything to the right. So now I want to think, well, how much data do I have to the left of it? This was the 10th position, so I have 9 pieces of data. So if I have 9 pieces of data, 9 plus 1 divided by 2, 10 divided by 2, tells me I'm looking at the 5th position. So 1, 2, 3, 4, 5 right here is what's in that 5th position. It happens to have a value of 5. Here's the Q1. Okay, for my Q3, it would be the same thing, 5th position. So I'm looking at, here's my median right here. I'm going to block it out and focus on what's to the right. So I'm going to have it in the 5th position of this data right here. So I'm looking at, again, I have 9 pieces of data, add 1, divide by 2, still 5th position. So 1, 2, 3, 4, and 5, it's right here. That's my Q3. It has a value of 7. So when I'm thinking about what my quartiles are, this one right here is the median of the first half of data, right? Because I'm looking at that first half of data right there. And then this one right here is the median of the second half of data. All right, so then I want the range. So range is max minus min. So 9 minus 3 is going to get me 6. Okay, and then IQR is the difference between the quartiles. So Q3 minus Q1 is that spread of the middle half of our data. So 7 minus 5 will get us to 2. All right, so then I wanted to do the same thing, right? I just wanted to do it with an even set of data. So let me slide this up. So if I have an even amount of data, in this example, I have 20 pieces of data. I know that my median will not be a standalone value anymore. So to find its position, I'm going to take, oh, this should be part A right there. So this should be 20 plus 1 divided by 2. So 21 divided by 2 gets me 10.5, right? That's my position. So what that's really telling me, since I don't have a 10.5 position, it's saying, well, we want you to find the average of what's in the 10th and the 11th position. All right, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Here's 11. I usually draw it like this. So I scoop them both up, do a little slash right there. And if I average 5 and 6, it's going to be 5.5. So this is my median. This is my Q2. My second quartile has a value of 5.5. So again, when I have an even amount of data, my median will not be a standalone value. It's going to be the average of what's in the middle two positions. All right, so now I want the Q1. So I'm looking at here, I'm blocking out everything that is to the right of that line, and I should recognize that I have 10 pieces of data. So if I have 10 pieces of data, add 1, divide by 2, 11 over 2 gives me 5.5. So my first quartile will be the average of what's in the 5th and 6th positions. So let me write that down. Average of 5th and 6th position. So 1, 2, 3, 4, 5. Here's 6. And I'm looking at the average of 4 and 5, so I can see that that would be just 4.5. And that's my Q1. Okay, my Q3 will be the same, right? I'm just blocking out everything to the left of this little line here where my median is. I still have 10 pieces of data to the right, so I'm still looking at average of what's in the 5th and 6th position from this line. So 1, 2, 3, 4, 5, and 6. So I can see that it's going to be 7.5, and that's my Q3. All right, range, pretty easy. Looking at the max minus the min. So 9 minus 2, going to get me 7. And then the interquartile range, right, the middle half of data, the spread of the middle half of data. Here we're looking at 7.5, take away 4.5, and that gets us 3. Okay, so we should know how to find the median, the quartiles, the range, the IQR when we have odd data and even data. Okay, another thing to point out, when we use the median to measure the center of the distribution, the IQR is our corresponding measure of variability. So it goes hand in hand. If the median is our center, we use the IQR to describe the spread. However, if we summarize the center of the distribution with the mean is our average, then we use standard deviation to describe the variation of data values around the mean. So here, a short little preview to standard deviation. Last page. Let me get it in position. Okay, so slide it in. Okay, so standard deviation. So it's a measure of variability of spread to go with the mean. The figure tells us approximately how close to the mean most of the data values are. The formula for standard deviation differs slightly depending on whether you're using a population or a sample. So right now we're going to be dealing with a sample, and a sample implies it's a subgroup of a larger set of data. So here is our calculation. So I'm going to give you this formula, but I'm going to go through it with you step by step. So here we see this big ol' square root. This is the sum of the squared deviations divided by the number of data minus 1. So big formula to unpack, but I have it here step by step, and I'm actually going to do it with you in the calculator in example 4. I just wanted you to have this in your notes. So first we find the mean, we find the deviation of each entry, so how far each piece of data falls from the mean. We force those values to be positive, so we square each deviation. We add up all of those squared deviations. We divide by 1 less than the amount of data to get what we call the variance. and then we finish it off by taking the square root. So let me walk you through that, and I'm showing you how you do it in the calculator. So I'm giving you this little grid, this little table here to keep you organized, and that's just really to help you see how you would do it in the calculator before I show you the shortcut of how to just ask your calculator for standard deviation. It's important to me that you understand the mechanics first. All right, so we're given data on quiz scores over the course of a semester. So the implication is that we're looking at a sample, a subgroup of a larger set of data. Find mean and standard deviation. So first thing to recognize is that we have 10 pieces of data. So our n value is 10. Okay, we got to first get to our mean. So I'm going to start us off by plugging all of this data into the L1. So the L1 should have all of our raw data. And in this case, we're talking about quiz scores. So let's see if I already typed it in. I think I did. Oh yeah, there we go. So here is all of my data in the L1. So first thing I have to do is I have to get my mean. So I need to figure out what's the sum of all of my data in the L1. So I'm going to go home. I'm going to hit second stat. I'm going to go over to my fifth choice once I'm in math, my fifth choice. And I'm looking for the sum. So sum of L1, 870, and then I divide it by 10. But let me show you that one more time. So all of my data is in the L1. So I hit second stat. Once I'm over at math, it's my fifth choice. So that's how I get to the sum. All right, so let me write this down. So my sum, x bar, because it's a sample, was 870 divided by 10. So my mean is the sum of my data divided by 10, and then I get 87. So the average score is 87. Almost a B+. All right, then slide over a column. So in the L2, we're going to have all of our deviations. We're going to say, okay, we want to look at all of that raw data. It's in the L1. Let's take away the mean, which was 87. So again, this is deviations. How far each piece of data falls from the mean. So here we go. I'm up here. I'm back in my stat list. Okay, so I'm sliding over a column. I'm now in my L2. So up in L2, I have to be nice and black on the L2. I'm saying look at L1 and take away the mean. The mean is 87, and I hit enter. So it's giving me how far each piece of data falls from the mean, over or under. That's why I'm getting some negatives and some positives. So if I transfer those over, I have a -9, -7, -2, -1, 2, 2. Let's see. I think I got out of whack. Let's see. -9, -7, -2, -1, -1, 2, 2, 3, 6, 7. Okay, there we go. All right, so again, these are my deviations from the mean, how far each piece of data falls from the mean. So since we're some over, some under, we got some negatives, some positives. So now in the L3, we want to square those deviations. We want to force them positive. So we're going to say up in the L3, well, let's look at everything in the L2. Let's look at those deviations and let's square them. So I want here my L2 squared. So this is my deviations squared. So I'm forcing everything positive. So L2, so up here, second 2, got the L2 to pop up, and then I square it. So I hit enter, and that column fills up. And I know that all of these numbers, I picked pretty easy ones today, so they all end up being integer values. So you probably could have done this in your head, but I am still just trying to show you how to use the calculator when it gets more complicated. Okay, So now I have all of my squared deviations. So my data in the L1, how far each piece of data falls from the mean. So my deviations in the L2, L1 minus the mean was 87. Force those values positive, we square those deviations. So then next we need to get to the sum of the L3. So again, I need to go home. I go second stat, over to math, fifth choice. I want it to be L3 this time, so second 3, and L3 pops up just like that. And when I hit enter, I get 238. 238. Okay, so now my sample standard deviation. I'm going to have a big square root. Okay, I'm going to have the sum of the squared deviations, which we know is 238. I'm going to divide it by 1 less than my total amount of data, so 10 minus 1. So really, I'm going to type in the square root of 238 divided by 9. Okay, so here we go. I have 238, so I'll go ahead and divide it by 9, and then I'll take a square root of that answer. So I don't want to type in 26.44. That's not precise. I want to build off my previous answer. So if I hit second negative, let me slide up so you can see that. So second negative here, second negative, it gives me the previous answer. So I'm building off that previous answer like that. So I can hit enter. There's my standard deviation. I could have also just done it like this. Square root, in parentheses, 238 divided by 9, just like that. And you can see that I'm going to get the same thing. So either way, my standard deviation is about 5.14. We'll go 2 decimal spots, nearest 100. Okay. So then what does that actually mean? To summarize, we're going to say, well, this student typically earns an average score of 87. With a standard deviation of about 5.14. Okay, we're saying this is how far a typical value falls from the mean. So if I picture my 87, I'm picturing adding 5.14 and subtracting 5.14 and saying that that is where the bulk of my data should fall. Okay, we're going to add a layer to our understanding of standard deviation in our next lecture. I just wanted to give us a nice little overview. So standard deviation, we only attach it to the mean as our center. And we're saying how far a typical value falls from the mean. And we will finesse our understanding in our next lecture. All right, have a good rest of your day.